Today we're going over 6.1 solving system by graphing, and this is our warm-up. They want us to evaluate each expression for when x equals 1 and when y equals 3. So for this first problem, I'm going to plug in 1 for the x and -3 for the y. So it's going to be 1 minus 4 times -3 equals 1, and then -4 times -3 is positive 12. So therefore the first expression simplifies to 13. Now the second one is going to be -2 times 1 plus -3. So we're left with -2 minus 3, which is going to simplify to -5. Then for 3, 4, and 5, they want to write each expression in slope-intercept form. Now for number 3, all I need to do is add the x on both sides. So that's going to give me y equals x plus 1. Guys, remember slope-intercept form is y equals mx plus b. So this is what we're trying to rearrange everything to. Number 2, I'll subtract 2x on both sides. That's going to give me 3y is equal to -2x plus 6. Then I'll go ahead and divide everything by not by -3, but just by 3. And that's going to simplify to y equals -2 over 3x plus 2. That is your second slope-intercept form. For this third one, I'm actually going to move the 5y to the other side by subtracting it. So I'm going to get -5y equals 5x. Then I'll divide by -5 on both sides. And that's going to give me y is equal to -x. So therefore, these are my 3 slope-intercept forms for these last 3 problems. So by the end of today, you should be able to identify solutions of linear equations with 2 variables and solve systems of linear equations in 2 variables by graphing. Now, just so you guys know, a system of linear equations is going to be something like 2x plus 3y equals 7 and x minus 4y equals 13, for example. That is a set of 2 linear equations. And also when you're graphing, you're going to have, let's say this is the axis. You're going to have a line going that way and a line going like that. You're going to be able to identify what the solution is just based on looking at the graph. So a system of linear equations is a set of 2 or more linear equations containing 2 or more variables. So like the example we showed you in the last slide. And a solution of a system of linear equations with 2 variables is an ordered pair that satisfies each equation in the system. So if an ordered pair is a solution, it will make both equations true. Now, again, just so you guys remember, an ordered pair is going to be x, y. And if you guys notice, let's say the graph from the other slide, I'm just going to redraw it. The point right there that the graph intersects that's going to be the ordered pair solution, so the x, y. In the 2 equations, if you get, I don't remember what I wrote, so I'm just rewriting new ones, trying to remember close enough to what it was. You're able to solve this, you're going to get 2 points where this is going to be a solution. That solution is going to be, again, an ordered pair. We'll work on it throughout the slides, but your answer for these are always going to be an ordered pair, whether or not they are a solution or not. So here they want us to tell whether the ordered pair is a solution of the given systems. Now, in order to do this, you're going to have to plug the ordered pair, 5, 2 in this case, because this is the answer they're giving us, into the equations in order to solve for them. Now, I'm going to plug it into this first equation first. So I'm going to do 2 over 5. I'm going to plug in the 5, which is the x, so times 5, minus 2, which is the y, equals 0. So I'm going to multiply this. So I'm going to get 10 over 5 minus 2 equals 0. I'm going to simplify the 10 over 5 to 2 minus 2 equals 0. And then we get to 0 is equal to 0. So it did work for that first equation. So it is a solution for the first, but the key is they have to be a solution for both. So we're going to actually plug it into the other equation as well. And then for this, so I'm going to do the second equation. I'm going to do it in red. So we're going to do 3 times, plug in the 5 for the x, minus 2 equals 13. Now, 5 times 3 is 15. And then we're going to just rewrite minus 2 equals 13. Then 15 minus 2 is 13. And 13 does equal 13. So therefore, it's also good for this equation. Now, because this order pair worked for both, we know this is a solution. Now, key part, guys. The order pair must be true for both equations. So what does this mean? If you guys, for some reason, one of them doesn't work and it's the first one you plugged in, you don't have to keep going because it's not going to be a solution to the 2 lines or to the 2 equations. So if it's true in one, it has to be true in the other for this system to be a true solution. Before we move on, I want you guys to notice how in all of these, all we really did was plug in and simplified the one side with the variables. You guys do not have to move stuff to the other side to solve this. You plug it into the original equation, and then you just simplify until you get an answer. If it matches like 0 equals 0, 13 equals 13, then you know it's a good solution. Now, this helpful hint, it's already told you in the previous slide. It says that if an order pair does not satisfy the first equation in the system, there's no reason to check the other equation. So like I was just saying, this is just in other words. It has to be true in both equations. So if you happen to plug it into the first equation and it doesn't work out, then you don't have to do anything with it. So for this example, I want us to tell whether the order pair is a solution to the given system. Again, we're going to plug in the points into the equations. I'm going to call this equation 1. So I'm going to go ahead and plug that one in first. So negative 2 for the x, plus 3, positive 2 for the y, equals 4. So negative 2 plus 3 times 2 is 6, equals to 4. Negative 2 plus 6 is 4, so 4 equals to 4. It's true for the first equation. Now we have to try out the second equation. So negative 2 plus positive 2 equals 2. Now a negative times a negative 2 is going to become a positive, so we're left with positive 2 plus 2 is equal to 2. 2 plus 2 is 4. And we get 4 equals to 2. That is not a true equation, so it will not be a solution. So for this example, I also want us to tell whether the order pair is a solution of the system. And the order pair is 1, 3. Again, I'm going to call this equation just 1 and the other one 2. I'm going to go ahead and start with 1. I'm going to plug in the numbers. And then I'm going to go ahead and simplify. 2 times 1 is 2, plus 3, then we got 5. 2 plus 3 is 5, and 5 equals to 5. So we know equation 1 is true. And I'm going to go ahead and do equation 2. So negative 2 times 1 plus 3 equals 1. Negative 2 times 1 is just negative 2 plus 3. And then we're left with equals to 1. Negative 2 plus 3 is equal to 1. So 1 equals to 1, therefore this is a solution. So for this one, it's saying all solutions of a linear equations are on its graph. To find a solution of the system of linear equations, you need a point that each line has in common. In other words, you need their point of intersection. So this has to do with what I was saying earlier about how the graph, when it's the solution will be the point that they both intersect at. Now let's graph the lines. I'm going to do the blue one in blue and the red one in red. To go ahead and start, I'm going to put in the negative 1 for the y-intercept right here. And then I'm going to go up 2 and 1 to the right. Now I'm going to do a bunch of little points because I honestly cannot draw a straight line on here. So just trying to get as straight of a line as possible. Now, I'm going to do the same thing for the red. I'm going to start at +5, and then it's a solution, a slope of -1. So we go down 1 and to the right 1, or up 1 and to the left 1. Again, just trying to cross where they need to cross. When I do that, I realize right here, we have the point of intersection. The point of intersection is the only point that these two lines have in common. So, our point is actually at 2, 3. And sometimes, guys, you're not going to have a super easy graph to look at in order to be able to just look at it and solve like we just did. Sometimes it's a bit harder to find the dot. So if you have a hunch that what is the right order pair, you can always plug it in. I'll show you. You can always check your work. So I'm going to go ahead and plug it in right here. So I'm going to do 3 equals 2 times 2 minus 1. So we get 3 equals 2 times 2 is 4 minus 1. So 3 equals 3. So it worked for the first one. So that way you're checking your work. And then I do the same thing for the red. 3 equals negative and then 2 plus 5. Negative 2 plus 5 is 3. So 3 equals 3. So you guys know you chose the right points. Now you don't always have to plug them in. It's just more of a checking your work. I'll be doing this for the entire time of the slides, but you don't have to all the time. Again, this is a helpful tip. Sometimes it is difficult to tell exactly where the line crosses when you solve by graphing. It is good to confirm your answer by substituting into both equations. So this is exactly what I did before, which is just checking your work by plugging it in. All right, so they want us to solve the system by graphing and check your answer. So I'm going to do this one in red, and I'm going to do this one in blue. Now, the red one has no y-intercept, so we're at 0, 0, because there's no b. But the slope is 1, so it's 1 to 1. It's going to be, again, just drawing a bunch of dots so I'm able to draw this as straight as I possibly can. Now, to do the other line, we're going to start at -3. And then we're going to have a slope of -2, 1. So we're going to go down 2 and to the right 1, or up 2 and to the left 1. You guys notice I already drew the dot that they're going to touch and cross. So I'm just going to go ahead and draw this line right here. You notice that our point is right here. Our point is at -1, -1. So now it says to check your work, so I'm going to go ahead and plug it in. The red equation with the red, so we're going to do -1 for the y equals -1 for the x. That's true, so we know we chose a correct dot, or correct order pair. Then we're going to plug it in again for the blue line, so we're going to get -1 for the y. Equals -2 times -1 minus 3. So -2 times -1 is +2, and then minus 3. We get that -1 is equal to -1. So we know it worked. Therefore, we chose a order pair that worked for both of our equations. So we know this answer is true. So this is a solution, -1, -1. All right, so for this one, they want us again to solve by graphing and to check our answer. So again, I'm going to do the top one in red and the bottom one in blue. So I'm going to start at -1 for the y-intercept. And then I'm going to go down 2 and to the right 1. Again, I'm just plotting a bunch of points to make sure I'm able to draw this as straight as possible. I clearly failed, but it's okay. And then the second one, we're going to start at +5, and then we're going to have a slope of 1. So obviously, you guys notice I already went through the one that's going to touch. And if you notice, that point right there is actually -2, 3, right here. Now time to check. We're going to plug them into the red and the blue. So 3 equals -2 times -2 minus 1. 3 equals -2 times -2 is +4 minus 1. So 3 equals 3. So it works for our first equation. Here again, we're just checking our work. And we're going to do the same thing for the blue. 3 equals -2 plus 5. And 3 equals -2 plus 5 is 3. So we get that this is a solution for both equations. So let's solve these two. Again, I'm just going to call this one 1. We're going to go ahead and plug it in. So 1 equals -1/3 times -3. Let's solve it. So we get 1 equals -1/3 times -3 is +3/3. And that simplifies to 1 equals to 1. So the first one works. Just plug it into the second to see if it's going to work. 4 times 1 plus 12 equals 3 times -3. 4 times 1 is 4, plus 12 equals -9. This is going to be 16 equals to -9. So, no, it does not work. The second one doesn't work. If you happen to plug it into the second one first and notice it wasn't true, you could have stopped there. I plugged it into the first, which just happened to be, it did work, so not a solution for this system of equations. Now I'm going to go ahead and do the same thing for number 2. This is going to be -4 minus 2 times 2 is equal to -8. -4, -2 times 2 is -4 equals to -8. -4 minus 4 is -8 is equal to -8. So this one works. Now I'm going to go ahead and plug in the second one as 4 times -4 plus 13 times 2 equals 10. 4 times -4 is 16. 13 times 2 is 26. That equals 10. Then -16 plus 26 is 10 equals to 10. So then this one is a solution as 10 is equal to 10 and -8 it is equal to -8. So it is a solution. So I want us to solve the system of equations by graphing. Now, this equation right here, I'm going to rearrange it into slope-intercept form to make it a lot easier to work on. So I'm going to go ahead and subtract the 2x on both sides. And that's going to leave me with the equation y equals -2x plus 9, making it a lot easier to graph. Now, I go ahead and plug in my 9. We have a slope of -2 to 1, so I'm just going to go down 2 and 1 to the right. Again, this should be hopefully enough points. And then I'm going to go ahead and graph the other one starting at -3. We go up 4 and 1 to the right. So right here. So we see that we have the point right there that collides. And the point right here that we collide in is 2, 5. So being 2, 5, I can go ahead and plug it in to check. I'm going to plug it into the original equation. So 5 plus 2 times 2 equals 9. So it's going to be 5 plus 2 times 2 is 4 equals to 9. So 5 plus 4 is 9 is equal to 9. So it works for the first equation. I'm going to plug it into the other equation, the red one. So I'm going to be 5 equals 4 times 2 minus 3. So 5 equals 4 times 2 is 8 minus 3. And 8 minus 3 is equal to 5. So we get 5 is equal to 5, making sure it works on the other equation. So since it works on both equations, we know this is the correct solution that we picked. Now, before we finish, I do want to let you guys know we do have homework.